Hey everyone. So today we are going to cover a question that was asked in coding round for SD2 role in D show. So the question is a teacher needs to create a test from a group of questions. There are total n questions and each question has a cost associated with it given by an array cost of size n. There are m tags and each question satisfies or matches some of the tags out of those m tags. Find the minimum cost to create the test by selecting questions such that all tags are covered. There exists at least one question for each tag, and given below are the constraints like the number of questions vary from 0 to 700 and the tags vary from 0 to 12, so at max 12 tags can be there, and the cost of each question also varies from 0 to 10 raised to the power 9. So I'll give an example. So let's assume there are 3 questions and 2 tags, and the cost of these questions is 2, 6, 1, and correspondingly these cover basically the first question covers what all tags, so that is given by like 1, 0. Second question covers both tags, and third question covers second tag. So basically the second question is covering both the tags, so that is one solution, but we have to find the minimum cost, so we'll select the first and the third question. So as the combination of these two, the cost is less, so the cost for that is 3 and we have to minimize the cost, so that would be the optimal solution. So selecting the first and the third question. Now I would encourage you guys to pause the video and try to solve this question on your own and think about it, like how you can proceed in the question. So take your time and start back the video when you are ready to check the answer. So this seems a simple question, but it is actually quite tricky. So I'll take another example. So here let's take an example. Let's see, we have m equals to 5, so we have 5 tags, and I'll create like those sets, how each question matches the tags. I'll create those sets. So let's assume we have 1, 0, 0, 1, 0, and then we have 0, 1, 0, 0, 1, also 0, 0, 0, 1, 1, and 1, 1, 0, 0, 0, and something random like 0, 1, 0, 1, 1. So these are the sets. So initially, like multiple solutions come into mind. One could think that let's sort all the questions by the cost and then select the least cost question and then check what all tags it fulfill. Like this, let's assume this has the minimum cost, it has a cost of 5 and rest all are big, like rest are 10, 15, 9, 12, something like that. So we select this and then we check that okay, this satisfies the first and the fourth tag. Now we move to the next, then we see okay, which is the cheapest. This selects first and second tag. Okay, so now select this, and similarly we select all the questions based on the cost. So this approach has a problem with it. So what if there exists some set, like we selected initially set x and y, and they have the cost for 4 and 7, so the sum is 11. And what if there exists some set z that satisfies both all the tags that are consumed by x and y, and its cost is 9. So initially, because we sorted the sets based on the cost, we selected these x and y sets, but the optimum solution would have been if we have selected the set that covers all the cases and has a cost of 9. But this cannot be done in this approach. So now one might think that okay, we can check, we can move forward and select all the sets and check if there exists any set that covers or that can replace two sets and reduce the cost. So for that, first of all, doing that is like very time consuming, so that would increase the time complexity. So how we'll do that? So first we'll check, okay, so for each set we'll have to cover, we'll have to traverse all the sets and check, calculate the difference of cost it is creating, and if it is reducing the cost, we'll select it, and similarly we'll move forward. But this also has a problem. So let's assume that there exists a question or a set X that fulfills tags 1 and 2, and Y fulfills tag 3, and but this has cost of again 4, 7, and then there is that fulfills first, second, and third, and it has a cost of 9. So we'll go ahead and we'll replace this 4 and 7 by 9. But what if there exists some another set, let's suppose U and V, and it covers uh, 1 and 3, and it covers 2. So this it has a cost of 5, and this has a cost of maybe I'll take 4 for now. Basically let make it some bigger number and then basically adjusting that. So the point is that there might exist some different sets that satisfy all these tags and have and still have less cost compared to Z, and it might also be the case that this combination covered more tags, but we didn't reach this point, because once we have sorted, we have counted X and Y, we removed these two with Z. Now when we move to U and V, we'll see this only selects 1 and 3, and we need to select 1, 2 and 3. So we won't replace Z by U separately and V separately. We need a combination of this, only then we'll be able to separate. So going this way also we cannot achieve our solution. And apart from this, one might also think that this might be solved by DP. First we need to select one tag and see, okay, what question satisfies these, and selecting the minimum cost question for that, and then selecting two tags, 1 and 2, and then going, okay, this first was fulfilled by 1, and let's see what is the which question satisfies the second tag and with minimum cost. But there might exist again a third question which satisfies both these tags, whose cost is more than separately, like the first and the second question, but is less than the combination of those low cost questions. So DP will also not directly work here, like creating a matrix and going in that way, that also won't work. Now moving to the part where we see, okay, what is the actual solution for this question. So moving to the solution, I have selected this sample. So these are the costs, 25, 42, 39, these are the costs of each question, and these 100, 11 are the corresponding tags for those questions. So what we will do is we'll select each question, like first we select the first question and combine it with all other questions. So selecting the first set 10011, we'll combine it first with the second set, so that becomes 11011, and the cost becomes 42 plus 25, 67. Now what we'll do is we'll check whether this set already exists in our already existing sets or not. If already existing, what is the cost? If it has a lower cost, we'll keep it and we won't add it. If it has higher cost, then we'll remove that set and keep this set. So we have 11011. So as of now we don't have 11011, so we'll keep it. Now moving to the next, so we select first question and now the third question. Combining these two will create 11111. Okay, nice. This creates the complete, this satisfies all the tags. So we'll sum the what would the cost for this. So 39 plus 25 is 39, what is 25, okay, 64. And we have one solution. This might not be the optimum solution because we still have multiple sets remaining, and some other combination might cover all the tags with a with some less cost. So we'll keep going in this way. So now selecting the first tag and the fourth tag, first set and the fourth set, what will this create is 1 1 0 1 1. Now okay, now what would be the cost for this? The cost for this is 25 plus 15, so 40. So we see that this set already exists here and the cost is less, so we'll remove this and keep this one. Similarly, we'll traverse through, we'll combine the first question with all the questions and similarly keep creating sets in this way. And when we are done, we'll remove this set and add all the newly created sets in the list. Now we'll do the same thing with the second set, combine it with all and then even with the newly created ones, and then add those and remove this. Similarly, we'll keep going in this way. And what this will do is, in this way we are creating new sets with higher cost and like increased cost and covering more tags. So our aim is to cover all tags with least cost. In this way, what we are doing is we are checking each possible set creation, and we are keeping only the lowest cost for that set. If some new set is getting created covering all those tags and has a lower cost, we are adding that and removing the previous one. So in this way, we are creating questions with minimum cost and covering more tags. Similar, if we keep going this way, we'll reach a point where we cover all the tags and we'll have the minimum cost possible solution. So this is the complete solution. But this also looks a bit tacky or a bit laborious, like this, selecting each question and going through the entire list and then selecting another, then going through the entire list. So this is also a bit troublesome. So what we can do to improve upon it is that, since we know that the number of tags is 12, so at max there can be 12 tags. So yeah, there can be at max 12 tags, like 1 2 3 4 5 6 7 8 9 10 11 12. So what we do is we assume that this is a binary number and we'll create a number out of it. So the maximum number that can be created is basically 2 raised to power 12 plus 2 raised to power 11 goes to 2 raised to power 0. So this would come out to be 8191. So minimum would be only like zeros and then at last one. So minimum would be 1 and maximum would be 8191. So this is the range. Now when we have this initial set, what we'll do is we'll read each set and create a number out of it. Similar, like for this it would be 0 1 2 3 4 2 raised to power 4 plus 2 raised to power 1 plus 2 raised to power 0. So it would be 16 plus 2 plus 1, which is 19. So this number that represents this set is 19. Similarly, like we have for others. So in this way if we go, but good thing we can achieve is, once we travel all the sets, now when we are creating new sets, we have to deal with these numbers and not have to traverse these complete sets to check whether it matches. When new sets are getting created, whether it matches with the already existing set. For that we don't need to traverse the set. What we can do is whether this number exists in set or not. And for creating new sets, what we can do is we'll take like we have 19 for the first set, and for the second set we have 2 raised to the power 3 plus 2 raised to the power 0, so which is 8 plus 1 equals to 9. So we have 9 for second and 19 for first. So what we can do is we'll do a bitwise OR of these two numbers, so 19 or 9, and this would create some new number which is 19 and 9, which would create like 11011, and this would create 11011, and this would be our new number, and we have a corresponding number for this, which is I guess 19 plus 2 raised to power 3, 8. 18% 27. So we'll have a new number and we can check, okay, whether this number already exists in a set or not. If exists, then we don't add this number and the corresponding cost, and if it does not exist, we'll add this number and like also add that cost. So in this way we can proceed and cover the solution. So basically this was the solution, and there is no online link present anywhere that covers this question and provides a solution. Like if you search on Google, you won't find this question, and like I myself have tried to come up with a solution. I'm not sure whether this is a perfect solution or not, but yeah, this is a good solution that would work. And if you guys ever find out some link to some question online, please do add that link in the comment section to help others. Yeah, and I would encourage you guys to note all this entire set down in your notebook and try it out yourself, so that you get a good understanding of how it works, and like how we are obtaining the solution. This question is linked to some set theory. I'll also add that link in the description, so do check that might help you gain a better understanding of this type of question. But yeah, this is a very unique question and I have never seen such type of question. I tried to come up with a solution myself. I don't know whether this is the best solution or not, but yeah, this is a solution and I thought of creating a video and uploading it. So yeah, that's it. Thank you guys for watching it.